Let us verify Rolle's theorem for the function fx equal to sin x on the interval 0, pi. So we want to verify Rolle's theorem for this function. Now if we want to verify Rolle's theorem, we need to make sure three criteria are satisfied. First one is f is continuous. Is this function continuous? Yes, fx equal to sin x is a continuous function. So fx equal to sin x is continuous, in fact throughout R, but we don't need throughout R, we just need to show it on the interval 0, pi, and which is a subset of R. If it is continuous throughout R, then it must be continuous on the interval 0, pi. So the first criteria is satisfied. What about the second one? We know that fx equal to sin x is a differentiable function. Further, even we know that derivative of sin x is cos x. Once again, f is differentiable throughout R, so it must be differentiable on the open interval 0, pi. Lastly, whatever the value of the function at the end point, here end points are 0 and pi, so how much is f of 0 equal to? F of 0 equal to sin 0 equal to 0. And what about f of pi, f at the other end point? F of pi is equal to sin pi, which is again equal to 0. So the three criteria are satisfied. First being f is continuous, yes it is continuous. F is differentiable, yes it is differentiable. Value of the function at the end point are equal, that is f of 0 equal to f of pi. Once again, f of pi equal to f of 0. The value of the function at the end point are equal. So we can say that Rolle's theorem is applicable. So the Rolle's theorem is applicable for fx equal to sin x on the interval 0, pi. Now if Rolle's theorem is applicable, then Rolle's theorem guarantees us a constant c such that f dash c equal to 0. Now once the Rolle's theorem is applicable, then Rolle's theorem guarantees us a constant c such that f dash c equal to 0 and that c lie in the open interval 0, pi. Now if Rolle's theorem guarantees us such a constant, we should be able to verify that such a constant exists. So f dash c equal to 0 and c lie in the open interval 0, pi. Now once again fx equal to sin x. Now we know that derivative of sin x is cos x, so f dash x equal to cos x. Then what about f dash c? Of course, we will simply write x by c and say that f dash c equal to cos c. Okay, so far so good. F dash c equal to cos c. Now f dash c must be equal to 0. F dash c equal to 0 if cos of c equal to 0. Therefore, f dash c equal to 0 if cos of c equal to 0. When is that possible? That is possible if c equal to pi by 2 plus minus pi by 2 plus minus 3 pi by 2 and so on. But Rolle's theorem guarantees us existence of a constant c such that f dash c equal to 0 and that c must lie on the interval 0, pi. Does such a constant exist? Yes, we can see that such a constant exists. We can take c equal to, we choose c equal to pi by 2. Then we find that f dash c equal to 0. Then f dash c equal to 0 and c equal to pi by 2 is greater than 0 and less than pi. So we have verified Rolle's theorem.